Alright, so I'm going to continue my instruction here on pointers, working from Chapter 9 of the Gaddis textbook. I want to focus on arrays here and working with pointers and arrays. Alright, so I'll go back up to my example here, and I'm going to change a couple things here. So let's start with using some C code, because there's no reason I can't compile that with my GCC compiler or my G++ compiler. But let's write some things here in standard C. So I'll use the standard C standard IO header file, and let's just see what we need to change here. So I don't have anything really that interesting just yet. I have declared an integer array of 3 elements. After declaring it, I've assigned it the values 30, 40, and 50 respectively, and then I just have another integer declared out here that I'm going to use as an iteration tool, and I'm going to write a little loop. I'll say for I equals 0, I is less than 3, I plus plus, and what am I going to do here? I'm just going to use a printf, and I'll just print that out to the screen. So I'll use, I want to print out decimal, I'll leave a space in it, and then what am I printing out? I'm num, and then I need to put the index element in there, which is I, and then terminate the statement. And then I'll do, after I run through my loop, let's go through and we'll just do a carriage return just to tidy things up. Alright, and so all I'm going to do is just print out the values that are stored in my array with 3 elements. Okay, save it, back over here, we'll compile, and now we'll run it. Alright, and it does it exactly kind of what we expected. It's going to display the values here. Alright, nothing that's super interesting. Let's play with a pointer now, so I'm going to go ahead and declare a pointer. I'll call this num pointer, or end pointer. Alright, and so I need to do what? Well, it's a little different when I want to assign an address that's really an array. I'm still going to use nptr, and I could point to an individual element, but I want to point to the entire array. So I'll just say point to num, and of course I don't need to use the address operator here because it's an array. Alright, and so I can go through here and let's iterate through this, and this is what's really interesting here. So if I want to iterate through this, well, first I want to say, let's just have it print out asterisk nptr. Alright, and of course that's just going to continually print 30, 30, and 30. Let's verify that. Alright, because I'll iterate through 3 times, but this never changes. It'll always be whatever I've assigned here, and this will be the first element of the array. So we'll compile, we'll run it, and you can see as predicted we have 30, 30, and 30. Alright, well, I want to iterate through this, and what I want to try to do here is I want to make sense out of this so that I'm going to point to this, and I'm going to increment it. Now check out this notation because it is interesting, but I'm going to go ahead and increment this pointer based upon whatever my iteration variable is. Alright, so the very first time I run through this, nptr is going to be, well, this value that I'm pointing to is going to be whatever that address is. Oops. Put that in there. It's I. It's our integer we're going to iterate through. So first time it's just going to be nptr. The next time it's going to be nptr plus 1, and then it's going to be nptr plus 2. And what we're going to do with this is go ahead and print those 3 elements just like we did before, but we'll use a pointer now to print to it. Alright, so I think I'm short. What am I short here? 1 parentheses. I'll finish that in, and it looks like we're syntactically correct. Let's verify that. I'll save. We'll compile, and now let's run it. Okay, very interesting. Look at the effect that I get. So I get 30, 40, and 50. Alright, well, let's do something just a little bit different. Instead of printing out the value that's stored inside of that, let's print out the memory addresses. So I want to see what memory address is stored at at num element 0, and then at num element 1, and then at num element 2. And what we should find, and we know that integers are 4 bytes each, we should find that we'll have a memory address, and then a memory address incremented by 4, and then a third memory address incremented by 4 more. So I made that change, and I want to display it this time. Let's display these as hexadecimal numbers. So I'll save it, and that's my hexadecimal operator, the %x. And so compile, let's run it now. You notice here are my different memory addresses. Alright, so in this particular example we're at 2C, and if we add 4 to C, that will take us D, E, F, and then the next number is going to be 0. So I've moved over 4 bytes. And in my last element, I'm going to move it 4 more bytes, and so it's 31, 32, 33, and then here's 34. Okay, so now I'm displaying the actual memory addresses where each of these elements are stored. Okay, interesting, huh? Let's do one more example here. And now let's go back to, we'll work with, instead of the pointer, let's work with the array itself. And we'll do the same thing, and we'll try to reproduce this, but now we'll try and use num. Alright, so we're going to say num I, and if we go through with this, this will print out the numbers as what? As hexadecimal numbers. Alright, so 30, 40, and 50, we'll print out those 30, 40, and 50 by hexadecimal, or we could change this to decimal, either way will work. But that's not what we want to see. We want to see the memory location of those. So I'll use the address operator again, and I'm going to say show me the memory address for num element, and the first time I iterate through this it's going to be 0, and then the next time it'll be 1, and next time it'll be 2. In fact, what we should see is the exact same output that we saw in the previous example. Let's verify it. We'll save, compile, and then we'll run this. And lo and behold, we have exactly the same memory addresses. Okay? So, what are we trying to do here? Show how pointers can be used in relating them to arrays and memory addresses.